This is page 7 of your note packet, sample number 1, which is to factor a polynomial equation completely given one of its factors. So if we know that x minus 4 is one of the factors, then we know that one of the zeros would be at positive 4, and that's the first thing that we need to do. So I'm going to copy this factor just to show you, set it equal to 0, and solve, and x equals 4. So that means that one of our zeros is at 4. So we're going to use this 0 and we're going to divide this polynomial by that to get it to be factorable for us. We're not going to factor it when it's x cubed. We're good at factoring when we have x squared. So we're going to need to divide it to bring it down to be an x squared. So we're going to set up our synthetic division over here. So make sure you have no gaps in your equation. So I've got x cubed, x squared, x, and a constant. So here's my equation that I'm using. And in the box, I only need the coefficients. So I need 1, I need -6, I need 5, and I need 12. Out in front, I need what I'm dividing by. And since I know that 4 is a 0 for this, I'm going to divide by 4. Drop the 1 out, as always, when you're doing synthetic division. And then multiply in, add out. So 4 times 1 is 4. -6 and 4 is -2. -2 times 4 is -8. 5 plus -8 is -3. -3 times 4 is -12. And 12 plus -12 is 0. If you don't get 0 for the last number, you did something wrong. Since I know it is a 0, since I know it is a factor, I should get 0 for this last number value. If I'm not getting that, it means I have a remainder, and it means it did not divide evenly. So using this division here, we can write an equation for that. So the equation that we have here that we're going to factor in a minute, decrease the power by 1 again. So it was x cubed, so now it's x squared. So it's 1x squared minus 2x minus 3. So this is what we need to factor. So I'm going to bring this over here and factor it. Factors to be x minus 3 and x plus 1. And so all they wanted on this first part was all the factors, or to write it in factored form. So if it's completely factored, then the equation has to have the two factors we just found and the original factor in it. So it would be the original factor that they gave me was x minus 4, and then x minus 3, and then x plus 1 were the two factors that I found. So here it is factored completely, and that would be the answer to this top part. And then if they wanted us to find all the zeros, you just take those factors and set them all equal to 0 individually. And you get x equals 4, x equals 3, and x equals -1. So you've got 3 zeros right here for finding all the zeros.